In today's lab, we are going to measure the moment of inertia of a wooden disc. So there are two ways here is our wooden disc, okay? There are two ways to find its moment of inertia. First way is we can calculate the moment of inertia from the mass distribution. We know that from class that you can calculate the moment of inertia of a point mass. If it's a point mass, then it's very easy. It's just mass of the point mass r squared, where r is the distance from the point to the rotational center. If you have lots of point masses, then you just add them up. Sum mi ri squared. If you have a continuous body like our wooden disc, then this summation becomes an integral r dn, r squared. For a uniform, geometrical uniform body like our wooden disc, you can treat this as a cylinder, although it's a very, very short cylinder, and it's rotating around its geometrical central axle. Your textbook should have that formula. You can carry the integral out, and the result is I cylinder, but it has to be around, rotating around the axle will equal to a half mr squared. Mass of the cylinder, the radius of the cylinder. We can apply this formula to our cylinder and get, the only thing you need to know, to do is to replace the radius by the diameter, because in the lab we measure diameter rather than the radius. So you will get our first equation. We call that theoretical result, I CO is 1/8 md squared. That's the mass of the cylinder and the diameter of the cylinder. That is our first method. Another way to measure the moment of inertia is based on its definition. What is moment of inertia is the inertia against rotation. If I apply a small torque, it will get a smaller acceleration. If I apply a big torque, it will have a bigger acceleration. And inertia is the resistance against your torque. Okay, so what we are going to do is, there is our disc, okay, and it can turn around the center. We are going to apply a known torque, okay, not just me, turning it, but we are going to hang a mass using the tension of this string, and hence through another pulley, hang a little mass, and use this gravity to turn the wheel. So this torque is well defined. And what we need to measure is how fast this mass accelerates. You can derive this in your pre-lab. Finally, you're going to get this equation. The moment of inertia will equal to 4 times the acceleration, mg minus a d squared. So the second method, first method, you need to have a uniform cylinder. If this is a wagon wheel, this equation won't apply. In the second method though, because you're using the definition, you're going to turn it with a known torque and measure how quickly it accelerates. The second method will apply if this is like a wagon wheel with some funny mass distribution. Okay, so we look at these two methods, what we need to measure. This little mass will be given. We're going to use a 100 gram mass. So M is gram, value and uncertainty. gravitational acceleration, we're going to use the value that we have been using. And what other quantities we must measure? We must get for the other three quantities, they are the mass of the wooden disc, we need it in our first method. Diameter of the wooden disc, we need it for both methods, and acceleration. Okay, so these are the three data we need to know. Next, I'm going to demo how to measure this data.